Hello everyone, welcome back to my YouTube channel. This is Apurva from Sri Venkateshwara College of Engineering, Bangalore. Today we are going to discuss about the principles of complementarity and Born interpretations, which comes under physics. So first let us see what and all the contents it consists of. Overview of the principles of complementarity and Born interpretations. Importance of these principles in quantum mechanics. Brief explanation of how they relate to each other. So first let's start with the quantum mechanics overview. Quantum mechanics describes the behavior of particles at the atomic and subatomic levels. It revolutionized our understanding of physics in the early 20th century. Wave-particle duality is a key concept in quantum mechanics. So the next is the principles of complementarity. Proposed by Niels Bohr, the principles of complementarity states that particles can exhibit both wave-like and particle-like behavior. Complementarity empathizes the need for both aspects to fully understand a particle's nature. It represents a departure from classical physics where particles were described slowly as particles. So let's move on to the dual nature of particles. The wave-particle duality suggests that particles can exhibit characteristics of both waves and particles. Particles can exhibit interference and diffraction patterns similar to waves. Particles also display localized behavior characteristics of particles. So the next is the complementarity principles interference. Complementarity principle interference occurs when waves overlap and either reinforce or cancel each other. Observing interference patterns helps understand the waves-like nature of quantum objects. In case of particle interference, experiments are done with detectors. So let's move on to the wave-particle duality experiment. The famous double-slit experiment demonstrates the wave-particle duality. When a beam of particles such as electrons or photons is directed at a barrier with two slits, an interference pattern is observed on a screen behind it. This interference pattern suggests that particles behave as waves. So the next is the Born interpretations. The Born interpretation formulated by Max Born provides a mathematical framework for understanding the wave-particle duality. It states that the square of the wave function gives the probability density of finding a particles at certain locations. The wave function represents the probability amplitude of particles' positions. So let's move on to the probability and measurement. According to Born interpretation, the wave function collapses upon measurement, revealing the particle's positions. The probability distribution collapses to a single point. The measurement's outcome is probabilistic and repeated measurements may yield different results. So let's move on to the quantum superpositions. Quantum superposition refers to the ability of particles to exist in multiple states simultaneously. Superposition is described by the wave function which combines different states with different probability amplitudes. The wave function collapses to a single state upon measurement. So the next is quantum entanglement. Quantum entanglement refers to the phenomenon where particles become correlated in such a way that the state of one particle is dependent on the state of another. Entanglement particles exhibit instantaneous correlations regardless of the distance between them. It violates the classical concepts of loyalty and is a key aspect of quantum mechanics. So let's move on to the uncertainty principle. The uncertainty principle formulated by Werner Heisenberg states that there is a fundamental limit to the perception which certain pairs of observables can known simultaneously. For example, the more preciously we the measure of a particle's position, the less preciously we can know its momentum. This principle places a fundamental limit on the predictability of quantum systems. So let's move on to the complementarity and Born interpretations. Complementarity principles and Born interpretations are closely related. Both deal with the limitations and uncertainties in measuring quantum properties. They provide a framework to understand the wave particle duality of quantum objects. So, the next is applications of quantum computing. Understanding the complementarity and Born interpretation is crucial in quantum computing. Quantum algorithms exploit the wave-like and particle-like properties of quantum systems. Probability distributions play a key role in quantum computations. So the next is the limitations. Complementarity and Born interpretations provide a framework, but they have limitations. They do not provide a deeper understanding of the underlying mechanisms of quantum behaviors. Efforts are ongoing to develop new theories that can explain quantum phenomena more comprehensively. So, at last, the conclusion. The principles of complementarity and both interference are fundamental particles in quantum mechanics. They explain the limitations and uncertainties in measuring quantum properties. These principles have applications in quantum computing, cryptography, and other quantum technologies. Thanks for watching.